Control Alt Shift H. Okay, finally it's gone. Okay. Welcome everyone back to day 2 of the Godot beginner game development workshop for the ECE students. I'm Brendan and I'll be continuing on from what we have learned yesterday. So as a recap, we have made a game like this. We have a movable player, a mob that can attack us. Currently, there's no damage indicators. That's something for another day. And also a buggy death screen that we will fix today. Now, for those online or for those who are coming only for today, we will be using GitHub to help us manage the changes. As you can see, I have recommended and I have put up my repository, the entire game project, on GitHub under my account, which you can find on the Telegram announcement channel. Under there, I'm using Git, the open source version control system used by almost 90% of all software developers, to manage the changes that I make. Every single time I make a change, it will be recorded under the commits. And occasionally, I'll make the commit and push it up to the cloud GitHub for everyone else at home or on their own computers to pull the changes and synchronize with my project. This will reduce the amount of confusion and, as I hope optimistically, that it will prevent people from being completely lost. So in the software Git, you can actually clone the repository, much like what I can do right now. So for those who are unfamiliar with Git, you can actually just go to your GitHub desktop and you can clone another repository. To do that, you usually type in the URL of the repository, which I will shortly come over. And you go to my repository. And you can go to the code here and copy the link. If you don't want to do a synchronization, you can download the zip. That will return you a static folder, the project folder, that does not synchronize with the Git. You can type in the URL and you can choose a directory to clone it into. For demonstration purposes, I'll clone it to my desktop. And it will put that project folder over there. When I clone stuff, you will be receiving the latest commit, the copy of my project at that current checkpoint. You will, of course, make changes because you're following through with the workshop. And when you do, Git will recognize the changes. So as an example, I can run Godot and open that project folder I've just created. This project will be from the desktop, which I will navigate to right now. Yeah, this one. I will open the project Godot and import it. And from your screen, you should be seeing something like this, whereby you will receive everything that has been made and all the changes will be synchronized. Right? When you open the folder in Godot, unlike some other software, Godot will make changes to a metadata file. This file will always change. Now, typically you want to ignore this folder because it's very annoying. Every single time you open the folder just to read it, it makes changes. However, don't be confused by these changes. You do not actually change anything. Now, in a typical project, you will actually make some changes, such as saying that there will be a variable called health, and you make that like 100, for example. You don't need to follow. But if I Control S this, then in GitHub, it will show the changes over here. If more than one file has been changed, you can take a look at the GD file, which is where we change. And you notice that in green, the Git recognizes that changes have been made. In doing so, you can actually recognize, Git will recognize all these changes, and you can type a commit over here. However, since you're following through with the workshop, you actually don't need to commit anything. Now, if you are lost, you can actually just git pull. What happens is that now your project is desynced with the project because you have made changes by yourself that might be different from mine. For example, you named it health with a F or something. And you could make a desync, and therefore you should not commit. Because if you commit, it means that those changes will be on your project permanently. And therefore there will be a merge conflict when you pull, or just a conflict. So now when you fetch the origin and say that I want to make a change. So let's fix that nasty bug with the screen right now. Currently, the game over screen will appear on the top left corner over here. Now, this is something to do with control nodes. Okay, so now we're moving back to Godot, and you want to make this change. Under the game over screen, which is a user interface node, last time they called it control nodes, there will be a bunch of canvas items. Canvas item will determine how the properties here will define how it will be rendered on the screen, defining the viewport. So you want to search for a, wait, was it here? No. Yeah, you want to search for visibility. And there's this property called top level. If you search enough and you find this, it says exactly what we need. It says that it will not inherit the transform. In other words, the position of the parent. When we instantiate it under player, we look at the script and then we take this template, this game over screen. We instantiate a version of it, an object. We get we place it as the parent of the player, the parent of the player being the game, and we put it as a sibling. So it will be here as a child of game. In doing so, when a child of game is instantiated, it inherits its position, its transform, and it will be placed at the center where game is. Game is at 0, 0, because it's a 2D node. When it's placed there, its center will also be at 0, 0. And therefore, to prevent this from happening, you can actually press top level, and it will not inherit the transform from the parent canvas item. Okay, so now you press play, and we'll try to kill ourselves. Yeah, and everything is working. So that's how we fix it. Now back to yes.
So you don't need anything here. All you need to do is go to the inspector of the game control. So you can select this one first. And you select this one. And now you can access the properties. One of the properties is top level.
So now we go back to Git. Notice that we are going to have more changes. So this is the wrong one. Okay. Now I'm going to go back to my original one. It's very confusing because there's two of them, because I need 2 copies. So on, you can ignore this, but what I'm going to do is basically I'm changing the game over screen and I'm going to commit. So I've made a successful change. I fixed the bug. And afterwards, I'll say fix game over screen, spawning in center. And I'll commit. As me as a teacher, I will commit, and I will push. You don't need to do this. This is on my end. And I'll push it to all students. Yeah, please don't push, because I saw someone give me a merge request, and of course I'm not going to accept it. So I push it, I synced it with GitHub, and this project should be up there. So as a student, I will be on this version instead. I have changed I've added a health for the mod, and when I fetch origin, I'll fetch from the cloud, and it will notice that there is a change to make. Okay, now it will ask you to pull, which means I push to the cloud, you are outdated, you want to pull those changes. So I can press pull. And now on my student version, okay, yep. Most of the time you just want to stash your changes and continue. If not, you can actually just dispose of all your changes, because I mean, as arrogant as it is to say that I'm the ground truth, I'm the only word that is true. So that means that your changes are false. In a way, in other words, you can throw away your changes. Okay, so you can stash those changes and continue. Your stash, you can stash those changes, and a stash is basically a temporary storage, a buffer for you to keep those changes. You actually not going to use them ever again. So you can actually just delete them. To delete changes, oh my goodness, to delete changes, you can just right click over here, and there'll be a change, discard all changes button over there. You can, yeah. So you can, yeah, full commit, right? Yeah. Okay, so as someone who is following another person's repository, you don't need to commit. If you are, okay, next time if you become a software engineer, you will be having to do a lot of Git. And that's when you have to do stuff like committing, making a branch, and yeah, learning Git in total. As a contributor, you have to push merge requests and all that. Okay, let me start my thing. I forgot to do that. Okay, now I can zoom stuff. Okay. So I'll reload all those changes because I've just put them, which means that my project folder has changed. As a student, I'll reload and notice that my change is gone because I am synced with the teacher's repository. Okay, so that's the example of how to use Git. Okay, now that we are done with that, we'll move on to the actual content for today. Okay, let me get rid of the student's account. Okay. And let me go back to my teacher's version. Okay. So now we have added death state. What we want to do is to be able to combat. Currently, we are just a victim. We can only die. We can't actually kill anyone. So similarly, we want to be able to retaliate. And the way we retaliate is not by bumping into another person and causing mutual destruction. We are going to be able to summon a projectile. We are a ranged character, and we will summon a missile that can damage enemies. To do that, we will need to create a new projectile scene. This scene will now be instantiated on the fly, and you will summon it at your position and make it travel in the direction of your mouse, much like what the finished product will entail. Okay, so this will also deal with some vector maths, but interestingly, not that much. So to do that, we will now create a new scene. So if you, as a recap, you can create a new scene over here. This scene will be a missile looking thing. Okay, if you think about it, the type that it is just some kind of sprite. It has an area, a collision box. So this node is just going to be area 2D. Okay, it's just a base area 2D. Unlike the other nodes that we created, we have created character body 2D. We have created a generic node 2D. This time we will just have a area 2D. We'll call this what we want, a missile. Okay, and we will the Godot will complain again, saying that it needs to have a collision shape. To do that, we have two collision shapes to choose from. We always choose the second one, unless you have a very composite collision shape. We will always choose the collision shape 2D. Next, we want to add a sprite. Unlike dragging and dropping, which I've shown yesterday, we can also just instantiate a sprite first. And this sprite is empty. Its texture is empty. It's asking for a resource. To give it its resource, you want to search for an asset to give it. So in my assets folder, I already have organized everything for you. You want to search for your projectiles and use the tower defense tile 2 made by Kenny Assets. It's a free asset that you can get online. Okay, now I have provided the missile. It does not have a shape yet. This shape will define its hitbox. Okay. Now, usually when you define hitboxes, you create another area 2D and then you give it a shape. But in this case, this area 2D, right, this missile is just a floating hitbox. It itself is a floating hitbox. Now, if you wanted to collide with the walls, then this area 2D, you will want to make it such that when it touches the wall, it will disappear. Then in that case, you make this missile be able to have a mask 1, and then if it touches the wall, it will disappear. But we're not going to do that today. Today, we are just going to define this missile to be a hitbox. So to simplify things, we will reset all the layer and masks. Now, this thing is going to be hurting an enemy. And which layer does enemy try to mask for?
3.
Yes, 3. So we have defined it yesterday. The enemy over here will have a hurt box now that masks for 3. So before we give it its hurt box, let's make this missile exist in layer 3 such that the mob has a hurt box that scans or monitors for anything that is in layer 3. The way we code things will be to make it such that as a victim, you will code and receive damage. Rather than, there's another way of coding, which is making the missile sense the intersections and making it such that it can call the damage function on the enemy instead, or pass the damage. But instead, we're going to do the other way, whereby we are doing it as a passive retriever. So after you have defined the layer 3, you want to save this scene. Every single time you save the scene, we need to be organized. In this case, we have our assets folder in projectiles. We have a projectiles folder in assets, and now we have a projectiles folder in scene. In this projectiles folder, we will save our missile scene. All right, so if you take a look, then now you have many more folders, and now with a missile. Okay, then in the mock scene, you want to define a hurt box. Currently, it only has a hitbox to damage the player, but now you want to give it its hurt box. So to do that, if you know the drill, you will be familiar that you need to add a area 2D. It will complain again. So we rename it to be hurt box to not distinguish it from hitbox. We will add the collision shape as Godot defines. And here's the trick that some people were confused yesterday, which is basically to create a new shape. If you want to create a new shape, you will have to define the shape again. So we are a bit lazy. We want to make sure that this collision shape, which is the same as the collision with the map, the hurt box, is the same as the hitbox, such that we don't have to redefine the bounds again. To do that, you can copy by right-clicking a resource. A resource is given first by this little square, whereby it's asking you to create something new. Every single time you're greeted with this shape, this kind of box, it's asking you to create a resource. A resource is a type of engine-specific file, specific to Godot, that has its own format. In this case, we'll copy and we will paste. When you paste, you're only pasting the bounds of the box. You're not actually changing the position. Notice that the collision shape here is offset from Y by a few units. So we know that this is position 4, or you can just take this and move it down. To move it down, as a recap, you can use any of these tools over here to edit its transform. In this case, we want to edit it transform, its translation. To do that, we can press W to select the move tool. If not, you can also use the select tool by pressing Q and moving it, but I prefer to press W to move straight to the move tool. So now we have defined the hurt box. So with the hurt box, we can now receive signals from anything that is in layer 3. To do that first, we want to make sure that we can monitor or we can sense for anything in layer 3. So we'll mask for layer 3 while disabling all the other masks at layers. So now our hurt box will emit a signal. As you can see in the description here, it's trying to, I find this example very helpful. Object A will only detect and emit a signal if object B is in the layer. Okay, so that means that we can make use of the signal. Remember that signals will be in this folder or this tab over here. This tab will define the signals, and you want to add a new signal. Say that whenever an object in layer 3 enters my mask layer 3, I will emit a signal. I will do things. So I will connect by default all the default settings. It will create a receiver method called on about that you entered. Okay. In this case, we can start to define how the herding process works. It's similar to what we did yesterday with the player, so you can always take this as reference. Okay, so first thing we want to do is we want to create a exportable variable called health, and we want to define this as 100 floating point number. Okay, either you can define it as 200 or maybe even 10 if you want to say it's a glass cannon. But here we make the export annotation to show that we can edit it from the inspector over here. As soon as I press Control S, another variable will be added here, whereby I can define it as anything I want. Okay, but it will reset to the default value, 100 as I define it in the script. Now, with the error box entered, you want to receive the damage that was taken. Okay, so refer back to the player. The way that we did it as a recap was that we have the health. And then when someone enters our hurt box, we will take that person's damage variable and we will pass it to our receive damage function as an argument. Yeah, as an argument. This will be run here. And if I can be damaged, I will decrement my health by the damage that was passed. And then I'll die if my health is less than or equal to 0. Okay, in this case, it's a bit simpler for the mob. The mob doesn't have any mercy. We are not going to give it any vulnerability frames. So to do that, it's very easy. So the area, remember, is an area 2D. Even in the node, even in the signal, right, it also briefs you that this area is actually of area 2D type. Okay? If you forget that, then you can also use an annotation to make sure that you remember that this is an area 2D type. Okay? This is optional, it doesn't matter. Now, to reduce our health, we want to simplify by making using the CS1010 property or concept of abstraction, or is it called wishful thinking? I forgot what it was. What was it? But it's basically, yeah, I think abstraction. Basically grouping and organizing your functions to make it such that the name itself can tell you the whole purpose of the function. You want to receive damage, and you want to take this area's damage. Now, it'll be a bit confusing for now, but we need to plan out how we're going to take in the damage. This missile should have a damage function somewhere. Okay, a damage value somewhere to define how much damage to deal to any enemy who receives it. Okay, so this script will be possessed. We will create a script, we will define a variable that contains the damage, for example, 20.0. And this script will be attached to missile, the area 2D. So unlike what we did with the player, whereby we had to area being the hitbox of the mob, we get the parent, and then the script is here, right? The script has the damage variable. Unlike that, we are actually just going to access the damage straight away because we're going to attach a script here. And therefore, when you receive damage, we are back in the mob, by the way. When you receive damage from the missile, you just need to get the damage like this. Area.damage. Okay, we'll leave this for now. We haven't defined the receive damage function yet, but we want to tie up some loose ends being here. We want to make sure that this missile can damage people by first giving it its hitbox. This is complaining, Godot is complaining that it does not have a shape yet. Let's create a new shape because we cannot copy and paste any that exists at the moment. We will create a new rectangle. You can even create a capsule if you want to, but I'm going to create a rectangle because I'm rigid like that. You can make the fonts not muted, I think. Okay. Okay, can people check that they're muted in the room? Okay, thanks. Anyway, you can hold alternate, as you can see on the bottom right. I'm holding alternate, and I am making it such that the origin will be staying in origin as I move the controls. So I'm gonna make it like this. Seems fair enough. And the method looks really ugly because of the import. I'm going to fix that for you. You don't have to do this, but I'm just gonna go here and I'm going to make it a preset of a 2D and re-import. Okay, never mind, doesn't matter. Okay, so now I have a hitbox. The hitbox will be the mask and the collision that will be defined in the area 2D. Let's make it such that this exists in layer 3. That I actually really did that. Yeah, sorry about that. And now we will define the damage that this will deal. To do that, we attach a script like normal here, and we will create it by using the default. So this is a create missile.gd. This is the default template. I don't really care about this. So now we're just going to have a damage. 20.0, for example. In 5 hits, I will kill the enemy. You can make this 50 because you feel the game is unfair or something. I'm going to make this 50 because just now in my finished product, I felt that it was unfair. So let's make the export. And so that now I can access it from here. And I can change it anytime I want. Okay. So this should work. We have layer 3, a mob that masks layer 3 using this hitbox. And when we receive it, we will receive damage. Okay, so let's define the receive damage function. Usually in my convention, I will leave the receiver methods, the ones that come from signals, be at the bottom. And so we will define new functions like this, receive damage. And then we will give it its parameter. So the parameter we want is the damage. Okay, this is not to be confused with the damage from the other one, but it's rather a local variable stored as a parameter and passed in. So this is very easy. We actually just need to just health minus equals damage. Every single time we receive damage, we are changing the health. To check that we are dead, we just have a simple if statement, health less than or equals to 0. And under the condition is true, we will die. And in the function die, it's a void function that does not, and also does not take in any argument. It will kill free the moment it dies. So this seems simple enough. Much simpler than yesterday. But for those who just came in only for today, this is a recap of how we actually define health. Except this is a bit more simple than what we did yesterday. Okay, let me do a sanity check. Okay. Health, physics. Okay. So this should work. Should work. And oh wait, hold on, I even started spawning the cells. Okay, yes. So to spawn the cells in the first place, you don't want to just instance. Whatever we've been doing so far is to instance things like this. Okay, we can do that. We can select a missile and we can instance it. Okay, you don't need follow, but it will be created just here, and it's not gonna hurt anyone. It's just there. It's not moving. It's not hurting anyone, and it's useless. Okay, so what I want to do is to make it such that every single time we left click, we will send this missile pointing towards my mouse and going towards that mouse pointer direction towards the direction, and also in the speed, at speed that we give it. Okay, so here's the kind of the fun part whereby we get to we can use our mouse and we can control anything we want. Okay, this will be defined under the player scene. Okay, before we do that, let me answer a question. Yeah? Any other questions? Maybe from Zoom. Let me check if anyone's asking. Okay, no one. Okay, so next we want to look back to our player script, where we're going to define the missile attacking script, right? The function will be where our player is, because it is the player emitting the missiles after all. So we will put it under missiles. Under player. So we want to define a function. It's just a level of abstraction. A function named shoot missile. You can put it anywhere. Luckily, this is not C, so there's no preprocessor crap that makes it harder every single time you arrange your functions. In shoot missile, you want to create a missile. We did a sneak peek of how do we instance scenes when they don't even exist in the scene, in the master scene in the first place. Okay, you can look towards up here when we did the game over screen. When we did a game over screen, you did not create a game, you did not instance a game over screen in the game. You don't make it invisible just so you can make it visible when you die. You created it on the fly. To do so, we can also do the same thing for missile. We will do a variable and we will define a class. In other words, in Godot, it's called a packed scene. This packed scene will be called missile with a capital M, because by convention, classes are named with a in upper Pascal case. And it will preload. Okay, now, like above, it's going to preload the scene. However, you might be asking, why am I using preload? Why is the pre for? Well, you also can use the word load, but load is a bit weirder. Okay, sometimes it doesn't actually return you a packed scene, it returns you something else. And not only that, but the number one thing is similar to Q3. Yesterday, I answered the question, why do we use Q3 and not free? It's because free is going to free and release the data from memory instantly, much like how load is going to immediately load the data on the fly. So what preload does, right, is that when the game engine class starts up, or when this scene starts up, it preloads the scene. In games, you will always see a loading screen. Your game takes a very long while to load up, and that's because the game is actually trying to load in the resources. In games, the most intensive, memory-intensive thing is to load will be images, videos, and things that are of higher storage space, like that take out like a few megabytes, for example. Same thing with scenes. Now, in our game engine, currently the scenes aren't that big. But in bigger games, it might take a while before you can load them. And therefore, the games would try to prevent you from seeing the entire game lag by loading that scene immediately, right? Because when you load it, then the whole game will freeze. It will freeze until that scene is loaded. And then after it's loaded and you can continue functioning, then the game will continue. To the game developers to prevent you from seeing that by having a loading screen. Okay, if you're doing a big game project, then that's something you might look at. To prevent loading because loading will depend. Sometimes you want to use preload, sometimes you want to use load. Most of the time you want to use preload to prevent loading from happening and causing disruptions to your game. Okay, so that's my explanation of preload. Okay, now we are presented with every single possible file in the game project. And what we want to search for would be the missile scene that we created. Okay, the missile GD, missile.tscn. tscn is a scene, so you press tscn. So now we have the missile class. The class doesn't do anything, it's just a template. We haven't instantiated it. So to do that, like we did with the game over screen, we will define a new variable with a small letter this time to represent an object. Instantiate missile class using the class as the template. Okay. So this missile class, this missile object will be created. However, it does not know where it's going to be created. Am I going to be created as a child of the player? Where will I be placed in the scene? For example, if I'm in the game scene, I press a button and I'm going to be shot from somewhere. Okay, what you want to do is that you want to emit this missile from the player. So you want to set the position of the missile to be exactly where the player is. Okay, let's go back to the script, to the player script. And when you shoot a missile, this missile will not have a position and will not have a parent. It's an orphan. Okay, that's what they call it. Yeah, if you see a debugger, right, there will be something that some game developers in a big game project they might oversee. It's called orphan nodes or orphan objects. Orphan objects are in vacuum. Yeah, floating in space. You can't get them, and they're not doing anything. So you might as well remove them from memory to free up space. So in projects, they want to reduce as much orphans as possible. Yep. Okay. So we'll tell the missile that it's okay. We want to place the missile somewhere first. So this missile object, right, will be placed. Let's plan it. We will shoot this missile in the object here. This missile will be under the game scene. Okay, and it should not be a child of player, because if it is a child of player, I can show you what happens later. But if it is a child of player, it will inherit its transform, which means that if I shoot a missile and the missile is like traveling in this direction at 5 meters per second, I move towards the right, by 5 meters per second, the missile will suddenly move at 10 meters per second. Okay, because it's inheriting the transform. Okay, so let's move on to the script, and let's say that we will make it a sibling. To make it a sibling, there's no function, but you just say get parent. Okay, you get my parent, my father, my mother, and then I add a child, and I'll get a sibling. Okay, and that's my missile added as a sibling. The missile currently does not have a transform. So to define its position, it will be by default it will be at 0, 0. So to make it such that it's at my position, I will want this missile, which is currently a node, okay, you have a global position. It won't prompt you because it doesn't know what missile is, like, doesn't know what's the type. Okay, but you trust me and you put global position. And you want to make this missile's global position be at your global position. Now, to a lot of beginners, this sounds really confusing. Like, why are there two global positions and what is this? So this is called scope resolution. When I put a dot next to this, I'm saying that this global position of the missile is going to be my global position. In other words, it's like this, myself. Who is self? Self is the player. The script that the guy who is possessing this script. This script being player.gd, player has control of global position. Okay, so you actually don't really need the self. It's just a shorthand. So when you put global position, it's referring to yourself. In other words, it's referring to one. This position here. Okay, but even this is confusing. You might be also asking, why is it global position? Why not position? Well, because position is relative. If any of you have played with like 3D software, there is something called global and there's something called local. Local means that my position will be relative to my parent, whereas global will tell me my position anywhere on the Earth. So for example, in Singapore, our latitude longitude would be like 1 towards the north and perhaps 46 degrees to the east. If you instead you are playing on a field in NUS, like a robotics course DG111, then you're playing on the course, that the coordinate system that you're using will not be the global positioning, the GPS signals. You'll be using your own map coordinates. based on the map position. So that's what I mean by different ways of representing the position. So to standardize everything, you want to make everything global position most of the time. So global position is most of the time what you're looking for. If you ever put position and you find out that your mouse is moving far away, then you can try global position and you'll probably fix it. Okay, so now we have the shoot missile and we'll spawn it. But how do we even trigger this function in the first place? Okay, no one's calling it at the moment. But what we know is that we want to use the left mouse button to be able to select it. Okay, so usually you want to put the input here. Okay, like what we did with method 1. Our input, to get the input left click you or even the up, down, left, right, you specify the class input. Okay, so something like that last time what we do. So you might be thinking, okay, we can put the input here under this method. We say, okay, input dot left click, and then we summon. Okay. However, as a method, as a word of advice for optimization, you don't really want to put input functions that don't really occur often, such as left click buttons, for example. Okay. This is the exception for movement. Movement usually happens every frame. So that's why you can put it under physics process. But in most other cases, you can actually have another built-in function called input. Okay? In fact, there are 4 of them. Now, let me tell you the difference between the 4 of them. One that we'll be using, right, will actually be unhandled input. Okay, this is the one we'll be using. I can tell you the distinction between the 4 of them. Input will take any input. However, most of the time in many games, you have a pause screen, a shop screen, whereby you usually be pressing left click to buy, sell, or to confirm the NPC's dialogue. So when you press left click, right, you want to shoot a missile. When you're talking to an NPC and then suddenly missile spawns from you. No, you don't want to. So what Godot does, right, to help you in distinguishing that you don't want the left click to be pressed when you're talking to an NPC or when the UI is popped up, is that it consumes all the inputs first by the user interface nodes. So user interface nodes will consume the left clicks first. Then anything that isn't consumed, either even eaten up or even sent by the user interface, will be trickled down to the lower priority unhandled input. Okay, that's where unhandled input means. It means that all those that haven't been handled by the UI will go down to me, unhandled input. Okay, so by habit and by good professionalism, we usually use unhandled input. Then there's also unhandled key input. That one is specifically for keyboard, not mouse. So we don't want to use unhandled key input. We want to use unhandled input because we're using the mouse button. Here, it's not much different from, oh wait, actually no, it is quite different from the input for something. Okay, here, right, they pass us an argument. This kind of helps us a bit. This event will be passed to us every single time there's an input, and it will tell us what exactly is this input. So you'll be wondering what is this type if you're curious. This will be an input event. Okay, it's different from input, but it's an input event. This input event has a enum, am I correct? No, it should have an enum or something. But yeah, you can always refer to the documentation by control clicking. If not, you just can press F1. Okay, F1 will bring up the whole documentation just in case you need to look for something that's not on your screen. Okay. Okay, remember it's F1. Why don't I have the clicker? Okay. My Connect isn't working. The one that tells me where I'm clicking or control. Okay, nice. Okay, never mind. Okay, so this is the input event. So here we want to sense the different type of input.
First is after strikes. I want to tell you that in missile you deleted the level.
Oh, right.
It's missing now.
Where? Sorry.
Up. By side. Preload missing.
Oh, okay, thank you. Yeah, Godot doesn't pick up that as an error because it's a string, and you think that strings are valid all the time. Okay, yeah, that's one of the things we get. Okay. So unhandled input, right? We will sense if event dot is action pressed. Okay. So unlike like event equals input or something like that, when it comes to input events, it's a bit different. Okay, this is just something that we have to get used to. So is in action pressed, is action released, is action. Wait, what's the is action just action is action press release? Okay. Okay, it's not here. Anyway, it's action pressed. And then you look through all the buttons that you have, right? None of them tell me how to click. Okay, this is where you have to define your own controls. Okay, now all this that they have given you, they have prompted for you, right? It's not suitable for all games. Some games have very funny funny key bindings. For all this, right, they're not suitable for your game. To do that, Godot provides you a setting that allows you to define your own inputs. To find this, you want to go to the project settings. Okay, project settings is here, just in case anyone forgets in the video, if we're watching the video. Oh my god. Yeah. Okay, project settings. And unlike the ones in general, you go to input map over here. Okay, input map. And here you can actually it's actually blank. But if you click on this, it will show you all of the default controls that they have given you. Okay, but all these are useless to us right now. So you can actually hide them. What we are interested in is custom-made input buttons. So we're going to create a new button. To do that, there'll be this prompt here called add new action. Our add new action will be called shoot missile. Okay. Why you don't want to call it left click is because left click is ambiguous. Left click next time might be used for different types. Let's say you search a game mode or you have a different weapon, then afterwards left click is very ambiguous. So what you want to do is you want to have different names for different actions. So next time if another left click, you just call it a different function like swing sword or something. Okay, we added this by pressing this button, and now we have a shoot missile. To actually give it its button press, we press this small little add event. Okay, we can have multiple events. We can have right click. You can also add right click to make sure that both buttons can shoot a missile. But for here, we are filtered to mouse buttons, keyboard buttons, joypad buttons for anyone using a controller, and joypad axes, which is something I don't know. But anyway, it's a joystick, I think. Anyway, we're looking at mouse buttons and we're looking at the left mouse button. There's even a middle button, there's the fifth mouse button, and that. But we want to press the left mouse button. The device could be all devices, and yeah, everything here. Okay, so left mouse button, all devices, and we close it. Now we go over here. We click on the open inverted commas, and we can see that there's a shoot missile over here. Okay, this shoot missile is a string referring to the project settings input buttons that you have given it. If the event is action press shoot missile, you will want to shoot missile. Done. Or if it's a function that doesn't take in any argument. Okay. Now, okay, if everyone is done and doesn't have any questions, I will do a sanity check. Make sure I am correct. Yeah, I call it left click. Bad example, sorry. Okay, damage taken, all that. What's the decision? Wait. Okay. All right, so we can press play, and hopefully, yes, I am laying a bunch of nuclear warheads on the ground. They do not disappear, and over time, if you do not free up your scene, they're going to cause a lot of lag. So let's make okay, there's a lot of problems here, of course. First of all, it's not moving. Second of all, it's not disappearing. Third of all, it's not facing the direction you want it to move. Okay? It's not rotating. Okay, so first order of business. Let's make the missile disappear. It might cause some lag. So what you want to go to, right, is actually the missile scene. Here, it will auto make it such that when the time is up, it will kill itself. Okay, a self-destruct button. So to do that, you want to have a timer. Okay. So like yesterday, we have invulnerability timer. We want to have a timer for its lifetime. Usually, I like to call this lifetime. Correct, yeah, lifetime. Lifetime being 5 seconds. After 5 seconds, it will disappear. Now, unlike yesterday whereby we have a vulnerability timer that does not auto start, we want this to auto start. So this timer will automatically start counting down when this missile is spawned in. Okay, this saves us the trouble of starting the timer manually via code. Okay, so to make this timer run a function when it finishes its duration, we go and create a signal. Okay, so we go back to our node, we go back to timeout, we double click this, and we connect the signal back to ourselves. On lifetime timeout, which means on lifetime duration has passed, after 5 seconds, I will queue free and myself from memory. Now, you can test this out by pressing play. And I click, 5 seconds. Is it not running? Oh yeah, it's gone. Okay, it's fine. Yeah, 5 seconds after it will disappear. 5 seconds seems like a bit too much actually, but yeah. Okay. Anyway, yeah, that's the lifetime. You can even set a distance limit if you want to.
Yes. So you connect it to this right? The lifetime is divided to itself, and then you do this. Okay. Yeah. So yeah, so you can control it when you're playing the game. But after 5 seconds you notice that it will okay, so like this. So you go back to players or the game and you press the big play button, then you can yeah. Oh yeah, then time. So currently, right, I need to comment something first, then I'm going to. So let me double check for you right now.
I haven't committed a long time, that's my fault, sorry. I should have committed every single time as a big change, like when I created the stuff. So this one is going to be missile time lifetime. Missile lifetime. Okay. So to just copy, I'll commit to the main branch, I'll push. After a while, it will be uploaded to the cloud. And then everyone who
refreshes by pressing the button on the top, it says that the repository has changed. And hopefully there's a full. Sorry? No. Please don't continue. Okay.
That's what,
Okay.
that's what caused me that in a second.
Upstream or more like the let me see. I had the weirdest one to go. Oh. What is good. It's a goal. They sense the change. Yeah, I'm not using NUSGDG. Even after like 2 years of doing this, I still haven't gotten something done. Yeah. Oh yeah. Okay. That changes. That's the next one. Okay. Oh, this thing is stuff. And you learn how about this. I don't know why, yeah, change the default. Thing. Yeah, yeah. Yeah. Yeah.
Okay, as a reminder, just stay on main branch. Hopefully everything will be correct. Git is sometimes a mystery. Okay. Yeah. So any other questions? Maybe from people on Zoom? Okay. So next, what I want to do is to make the missile move towards the direction of our mouse pointer. Okay. To do that, we want to get our mouse position first. So if you imagine our player can be here on the game. Imagine I am here. My mouse is pointing here. And this is my mouse. Then I'll spawn a missile and it will point towards this direction. So its rotation will be about 45 degrees. Negative 45 degrees. And it'll move towards that. Okay, so you can do vector maths, but that's a bit too annoying for us. But luckily, to deal with the rotation, right, our Godot has provided us a very nice function called lookat. Okay, so where am I? Okay, go back to the player script. When I shoot a missile, I will want to tell it what's its rotation. Let's make the missile's rotation, or sorry, make missile's rotation. Oops, I think it's rotate. No, I think it's lookat. Let me do a sanity check. Okay, it's lookat. So missile, lookat. Okay, now if you don't believe me because there's no prompt to tell you what is lookat, right? You can actually just say, you can actually just refer to this note. Yeah. So you can look at this one, and then there'll be a lookat function. So let's look at what lookat does. So lookat, right? It rotates the nodes such that it points towards the point. The point being the argument that you make, which is expected to use global coordinates. Okay, so very simple. You don't have to deal with rotation, maths, and all that. So to look at, I'll just look at something called the global mouse position. It is a built-in function that returns you where the mouse cursor is at the moment. So it's really neat and nice for us. So if you play the scene right now, you can notice that you can make a bunch of magnetic flux point towards the direction of your mouse. Very cool.
Yeah. You control quick, right? You can actually press this button. If you don't have a mouse or the fifth mouse button or fourth mouse button, right? You press this button over here to go back. Yeah. You go back. And now it's there. And now you look at the global mouse position.
There's no way you
The logo.
couldn't get an ace. There's no way.
Yep. Play a game. Yeah, so basically what I'm going to use this function.
You are currently connecting the direction of your mouse. Yep. Yep. That's pretty cool. So let me commit. Okay, habits. Add lookat function to rotate down. Okay, I will push. And that's it. Okay. So now we want it to move towards the direction that it's pointing at. Luckily, we already have defined the rotation. So all we need to do, right, is to actually just make it such that it moves towards this rotation. In other words, it moves forward. So all you tell the missile to do is move forward. You don't have to define the mouse coordinates again. You just need to say that go towards me. Okay. So that means that on the missile, we want it to keep moving in the direction that it is going at. So let me do a sanity check. Okay, so that means that every unit, every frame, right, we want to move towards a certain speed. Okay, so to do that, unlike the character body 2D that we had just now, right, we had something called move and slide that allows you to define the behavior of this physics body. However, for area, right, it's just a generic body. It doesn't have the move and slide function, unfortunately, because this area 2D can be used for many generic functions. So it's not that heavy on the built-in functions. It's not rich in the support that it gives us. So what we have to do is that we have to define our own physics process and give it its speed. Okay, every frame, my position, my global position. Yeah, if you use position of global position. Typically, yeah, I just use global position for now. Global position will be moved towards by 5 units. Let's define a constant called 5 units or the speed. Or not the acceleration. Oh, not acceleration, sorry, the speed, yeah. So we have a velocity. And this velocity is going to be 5 units. Every frame will move 5 units. So in 1 second, we'll move 60 times 5, that is 300 pixels. Okay, so that would be the velocity. Okay, then let me see. Sorry, this is not the right one. Okay. Yeah, okay. So global position is a vector 2D. However, what you're passing to it, right, is a scalar. So this is a vector, this is a scalar. They are not compatible. What you want to do, right, is to actually move towards that direction, in specifically the right direction. So you move towards the right, the rotation will do all the rest of the work for you. All you need to do is actually go back to the script and say that this velocity is going to be a multiplier of the unit vector right. Okay. Unit vector 2, there find a bunch of unit vector for you, and this is the right one. Okay, this will be 1 in the positive x direction. Okay, another thing that you have to define that we did not define just now, it's a kind of an advanced topic, delta time. Okay, I did brief you y'all about it yesterday, and I told y'all what is delta time. Delta time, which is this argument that is passed in, is the time that takes between 2 frames. If your game is really laggy, then you want to make it fair that by the time the lag finishes, right, you'll be compensated for the amount of time that has elapsed. In other words, if I'm holding right and I'm supposed to move 5 units per second, and it lags, the lag will actually take away that 2 seconds. So example, it lags for 2 seconds. Then I was supposed to have moved additional 10 units. But after the lag finishes, right, I'll be still remaining in my position because the delta time wasn't considered for me. I wasn't compensated. So to be like the government and to give your nodes the fair amount of movement that it should deserve, you want to multiply amount of time that has elapsed. Yeah, in milliseconds. Was it seconds? I think it's seconds. SI units. Let me check. Okay, sorry, it's called speed because I was going to define a constant, and I've defined it as 500. Okay. Anyway, this is just my copy. Okay, so sorry, this is too small. 300. 0. And we call it speed, and it's a constant. Okay. Now we redefine this as speed, and you all should be looking at something like this. Okay, any questions on Zoom? Okay, now we can try to play the game and see that stuff looks weird. Okay, so currently it's all right. That's because you have not rotated the vector. And we need to rotate it based on the rotation. So currently it's not linked to the rotation at all. What I want to do, right, is that you learn in MA 1512 or maybe A levels that when you have a vector, and you want to rotate something, you probably need to do some cosine or sine to tell you where's its direction. So I want to move in 300 units here, right? To make this 300 units in magnitude, your vector would need to be some number between that adds its magnitude to become 300. So luckily, Godot provides us another way to prevent that from happening. So this is the unit vector. We're just going to simplify it. This 300 is actually 300 times 1, 1. But now this is going to be 300 times this vector rotated by 45 degrees. Anyway, it's 45 degrees. So to do that, you can actually have a access all the functions of a vector, and specifically this one will be called rotated. Okay, and then you provide this angle. This is the rotation in degrees. Wait, sorry, this is going to be taking radians and radians. Okay, so you take rotation. Sorry, rotation. Rotation gives you radians. Rotation gives you degrees. Yes. Oh, yeah, sorry. So to make things simple, we just define the right vector 1, 0, and then we rotate anything by that. So as you can see here, right, we make right our default 0 degrees, just like in the polar Argand diagram. Where's my missile? Okay, so you notice that this missile, right, and under the inspector, we can actually play around with the transform. The rotation is 0 degrees, defined as the right. If I make it 45 degrees, it will be towards the fourth quadrant. Okay, now I can reset this to 0. Okay, now I can press play again, and everything works as expected. Okay, perfect. Also, I think I killed someone. Anyway, we can get rid of that instance I was showing you all just now. I'm going to get rid of this instance. If you have it, you may also delete it. Yeah, gotten that down. And now you can kill the enemy. So in a way, you can win the game, but let's make it a bit more difficult. Let's have a map. Okay, currently you're just playing on this gray screen. It's very boring. What you can do is actually create your first map. Okay, now we'll be diving into something called tilemaps, which is quite a big part of many games, especially 2D games. And what you want to do is that you want to get a generic 2D scene. A map doesn't actually have a specific node. It's just a place, generic 2-node 2D. And then we'll call this map. I'm gonna call this map 001 because maybe you have many maps and you want to perhaps append a bunch of digits to account for the number of maps you will have in the future. So in this map, right, I'm going to save this map as a new scene under a new folder called maps under scene. And then I'm going to save it as map 001.tscn. Okay, if you cannot follow, I'm going to commit. Okay. So I added missile rotation, missile shooting, and I also added a scene. Okay, so what we're going to do next, right, after I push, will be to create something called a tile map. Okay. This is one of the more confusing nodes in Godot. It has a lot of built-in features that the developers of Godot has provided for you. Now, what a tile map allows you to do, right, is to basically play Minecraft in 2D or Terraria. So, but first you need to define what is a grid or a box. To do that, you need to define a new resource. Just like in the collision shapes, we are going to have defined a new tileset. So you click on this, and then you're going to have the only option available, a new tileset resource. Okay, now you have this nice little looking grid feature. on the tile set again to access what this resource entails. It's going to be square and all these functions, all these parameters. Okay. Now you take a look at the bottom, and now you have two new things: tile map, tile set. Okay, tile map and tile set. What tile set is, right, is to define all of your resources, in other words, your PNG files, and how it's going to be utilized in your tile map. What tile map does, right, is going to be how it is going to be defined. Yeah, at the bottom. Yeah. It's a bit elusive. Okay, so for the tiles I'm going to be using, right, you can actually use any of the tiles here. You can even explore what is a tile, a sprite sheet. Okay, so if you look at the assets that I've given you, under maps, there are background tiles and there are tiles and there are backgrounds. For the tiles, right, there's the dungeon or the forest, all that stuff. It's a bit complicated for now, so I'm just going to use a basic PNG, specifically Stephen Harnham. Yeah, this guy. You see him if you're a computer engineer. But now you notice that his face is all cut up. Okay, his beautiful competitive programming face is all cut up. Now that means that I can actually just because when you insert it in, right, it has selected all these files. So what this tile set does, right, is that it basically acts as an importer. It imported this PNG. Now if I go back to my tile map, okay, go back to tile map, right, you actually are taking up all those grids, those small grids, and then you can define this. And then you can actually paint it like this. Okay. Now I can even take his mouth or something. Actually, I just passed by him just now. And then you can take his mouth everywhere and put it there. Okay. Or you can take like the blank space. So this is useful for sprite sheets because you can actually take out like one grid or something. Okay, you can also clear everything out. You can actually clear everything by I can screw it up. By taking this. So you have a bunch of artist tools here, like this square that allows you to define a big square. Okay, you can actually right click to erase and left click to place, right click and drag, and then you can delete everything. Or you can use this bucket tool. And if you have a bunch, you make a bunch of mess, like by placing this much, then it will delete all the contiguous files by pressing right click. Okay, it's not working, but I can just do this. Yeah. So I'll try to clear everything. Okay. So this is not what we want, but I'll go through it. Yeah, try not to move. Yeah. So for tile map, right, you try to keep the majority as much as possible. So the bucket tool doesn't work. Only if you are bound to something else, you cannot fill out the entire grid, which is going to be very expensive. Okay. So you want to click on this pencil, and then you okay. Sorry, yeah. To use the erase tool. Oh my god, yeah, W. Yeah, move more. Press Q. Go back to that more. Okay. So to fix this, we want to select this entire face. So to do that, we go to tile set to as an importer. We go back to tile set, don't be confused as a tile set right now. Back to tile set. Now we have all these textures. This is a 128 by 128 pixel. We usually use powers of 2. So this is going to be defined as 128 by 128. Define the grid size. The grid size is now the entire picture. So all you need to do is just select this, and yeah, basically here it has been selected. Okay, then you go to the tile map, right? Now the selection is just the whole picture. Okay, so now I select it, right? I'm going to select the pencil tool, which is D if you want to. And notice something is also wrong again. I'm placing him all over the place and he's overlapping himself, just like a Windows XP lagging screen. Oh, I got that. Anyway, so what happens, what is going on right now, right, is actually the tile in the tile map node is actually defined wrongly. On the right side, you will see another set of dimensions. This is to define the spacing in the node itself. This tile size can also be 128 by 128. Okay, now the grid is big enough to fit this as the grid. Okay, so now let's add another tile to make it such that the map looks nicer, even as ugly as it is right now. Okay, I'm not saying anything, but what we want to do is to use another image. You can use any image you want. Try to resize it to 128 by 128. But for me, I'm just going to use the default icon.svg. This is by far the most overused picture in all of YouTube tutorials. Okay, luckily this for us is defined also by 128 by 128, even though it's a vector file SVG. You go back to your tile set, you drag and drop it into this, and automatically it will be defined as a tile. There's 128 by 128 as well. Okay, so after you go imported it using a tile set, you go back to your tile map, and then you notice that it's there as well. You can select it, and using a pencil tool, similarly, it is added just like this. Okay. Now, let's give the map some shape. Let's make Stephen hugging the wall. Okay, he's like blocking you from getting your A minus. Yes. Oh. Okay, so what's gonna happen now, right, is that a tile will have a collision point to define that it has physics and that it can be collided with. To do that, we have to define the tile to have, or the tile map, sorry, to be a physics body itself. Okay, so we just focus on what's going on the left side, okay, and the right side. This tile map has a bunch of layers that it has. Specifically, what we want is a collision layer or a physics layer. So you go to physics layers, and we add an element. Okay. Now this is going to be in layer. Wait, sorry, layer one. Yeah, layer one, and it's not gonna mask anything. This is gonna be like a passive map. It's not gonna sense anything. It's not gonna run any code. So you want it to be a layer instead of a mask. Okay, so we set it as layer one, such that anything that masks one will collide with it. Okay, then now we want to make sure that this is specified by the specific tiles. We want the Stephen Hardin to be a collision shape, but we don't want the Godot icon to have a collision shape. So to do that, you go back to your tile set, okay, where you import your files and define its feature and its behavior, and you go to select. Okay, this one. This select will now tell you, will now tell you how you can edit the tiles. So by default, when you go to select, right, you're actually not gonna select anything. Okay, then you have to press on the right side of the tile to select the Stephen Hardin tile. Now, in physics, you will see a physics layer 0. Okay, this part is very easy to get lost. Okay, it's physics layer 0. What we have defined here, we have created a physics layer here. Now we define it here. Okay, we want physics Stephen Hardin to get a physics layer 0 to inherit its thing. But we want to define the shape of this tile's collision box. Okay. Now, by default, you don't have a shape. They will give you a polygon instead. So to define the points on the polygon, you press this green button here, and you select the 4 points of this shape. So this looks very trippy, right? You have an editor, you have an editor, you have an editor. So it's an editor and an editor and an editor. Now you want to press the points, the 4 corners, to define the polygon. Okay, once you've defined all 4 points, you have to go back to the first point to close the box. Okay, you can even if you have some trouble having with the grid snap, you can actually toggle grid snap and have grid snap enabled. Then this will snap to the grids. Okay. Okay.
Once that is done, then your single line has 1,000, but not the Godot. Okay, so now you get a line. After you have this layer, so all you do is press the green button. Now you can be precise. If you can result, you can enable the grid snapshot and go back and press the make sure that you press the front point that you had. Okay, now it's closed and polygon is closed. So
now we will want to define our tile, our map. We have set up the tiles, they all look right. We will now go back to the tile map and we will place the shape of Stephen Harlin over here. Okay, now I'm going to define the walls of the map like this. And I'm going to make the shape like this. Okay.
Listen.
yeah,
Even Harlan is okay.
it's very unintuitive, I know, but this is the new feature, by the way. Yeah, this is what they expected you to have is many different tiles in that window, so that you can select like a shopping list of tenants.
Okay, yeah.
Okay. And then I can fill in the Godot with the rest. Okay. Now, why we need a Godot later on, right, is something called navigation that allow the enemies to have pathfinding. Okay. Now we'll save this, and we'll go back to our game, and now we will add the map that we have just created. Okay. So this map is not being used. We're going to go back to the game. We're going to Control Shift A, or you can just right click instantiate, and we're going to add the map 001. Okay. Now, this map is the bottommost child. It's going to cover everything else. So you want to move it up to up here so that you can see the rest of your children. Okay. Currently, the player is stuck in the wall. Let's move him to here, or anywhere you want. You can press W or you can press Q to select and move. And for the rest of the mobs, right, you can actually just select all five of them by pressing Shift. Okay, you select one and press all five. You can move all five of them at once. Okay, or you can delete the rest out if you choose. But I put them here, and now I can press play. Okay, notice I can't touch the walls. The walls work, and everything is planned. Okay, so I'm going to commit it down and move on. We will select one more. Select the last one. And you select all. Now you press W and move. Okay. 35. Add map and collision off. Not sure. Sure. That's why you haven't done the rotation. Go back to your layer team. Turn on mark this out here with your script. So rotated and position. Position. Time position. This is for I think it's on your mask. So you delete this is regarding your rotation. The rotation is not rotating. You go back to the layer. Every time I strip the top, you want to look at is the okay, can you try to Okay, so next, we want the enemy to chase you. This is when we get into enemy AI. So luckily for us, in Godot 4, they have implemented some neat new features that allows you to have enemy AI pathfinding. The pathfinding in 2D games is rather simple. It uses something called A-star algorithm. A-star algorithm is basically just Dijkstra's with a bit of heuristics involved. This is something you might learn in CS 3243 if you want to take that mod. Something called Introduction to AI. One at the door. Okay. 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 So what we want to do, right, is to let me do a sanity check for now. Okay. What we want to do is that we want to make the enemy generate a path to the player while also navigating throughout obstacles. Okay, it doesn't want to hit the obstacle. And so to do that, Godot has this neat new thing called navigation agent 2D. Okay. Navigation agent 2D as a child of mod will help you to navigate around places. This thing generates the path for you. Okay. However, it doesn't know when to generate the path. So what we're going to do is that we're going to generate a path every 5 seconds. Okay. So to do that, we want to add another child to the mod called a timer to loop this function a few times. Generating a path using AI algorithms is a bit or graph algorithms. It's a bit intensive on the computer. So you want to do it as minimal as possible. In other words, you want to do it perhaps 5 seconds. Or perhaps no, sorry, 1 second. Every 1 second. This will be a looping timer and it will auto start. Okay. So it will auto start, and then by now you should know that we need to connect the timeout signal back to ourselves so as to connect it to make it loop. Okay, on the timer timeout, I will make my navigation agent pass call a function. So remember the shorthand for getting a node path is the $sign. The $sign, and I want to call my navigation agent to the child node, and I want to get a Right, let me do a sanity check. Yeah, okay. Okay, so it actually doesn't generate a path. It more like it set a target first, a destination. So it has this property called target position. Okay, a target position is going to be equals to the player's position. So to get the player's position, you know that in the map, in the game scene, right, the player is going to be a sibling of you. So it's going to be the get parent, the get node, which is your sibling, and you want to get the node player. Okay, we know that this is going to be called player. Okay. And you want to get this global position. Okay. Global position does not prompt for you. Okay. Get global position. Okay. So now that we have done this, we need this to run every 5 seconds. Okay, or every 1 second, which is already done. Okay. Then now if you play the game, let's see what happens. Nothing happens. You know why? It's because oh shit. No. Okay. Okay. That's because the map, the enemy, right? The enemy AI. This is yeah. Okay. The enemy AI does not know where it can go. It has a path towards it needs to generate a path towards the player, but it doesn't know that the ground it's standing on right now is an eligible path. It's something that it can navigate into. So we have to define it for it. And that's the purpose of the Godot tiles that we have. We need to define something called a navigation mesh. Okay, which is basically a plane or a shape in which the navigation agents recognize it as a place to move around. Anything outside of it, right, is forbidden area that it cannot move. So that's why in games, right, it's easier to define a place in which your enemy can move or your AI can move, rather than defining everything that it cannot move. Okay, so we go back to our tiles map. We go to our tile, and we go to tile set. Okay, under Godot, you want to do the same thing just now, whereby you select this tile and you have a navigation. However, this tile map does not have a navigation yet. You want to go back to inspector, and you want this node to have a navigation layer. Okay, to do that, you need to add a new navigation layer, add element. Okay, let's hide this for now. Navigation layers will have a new navigation layer, a new one. Let's just call this 1. You can define a name for it if you want to, but I'm just gonna leave it simple for now and have it as 1. Now, I want this layer to be on this map. So you go here, and now there's a new navigation layer. Okay, you select this, you go down here, and you can define the navigation layer. I'm gonna set a grid snap just so I can do it. Okay, so let's do something like this. Okay, 1, 2, 3, 4, 5. This whole tile is navigable. Okay, later there will be a problem. I'll tell you about it. Okay, but let's think that this will work for now. Okay, so I press play. This is the navigation layer. Okay, it's not running. Hold on. My tile set layer 1. Oh yeah, there's this one. Pathfinding, navigation 1. Star, half the 20. The avoidance about no. Oh yeah, okay, that's because we haven't even told the movement of the mob. So the mob, right, currently does not have a movement. Luckily, it's a character body, so it's easily defined. We just need to set the velocity towards the direction of where it's going. But we cannot just directly set towards the position of the player because it will collide to a wall or there's a wall in between it. Instead, what we can do, right, is that we can use the path generated by the navigation agent to get to the next line. So what the navigation agent does, right, is that you have a wall and you have a mob here. You have the player here. And then you have the mob here. To get to this, right, this point, the navigation area actually generates a path for you. And it knows to go around rather than to go straight through. Okay, so instead of going straight through, right, it generates a path for you. So all you need to do, right, is follow its advice and get to the next point. So what this does, right, is that it has a bunch of points, intermediate of it. And all you need to do is just get to the next one. Follow its advice, go to this one first. Okay, to do that, all you need to do, yeah, I'm gonna just copy this. Is to define its physics process, like your player movement. So function, physics body, physics process. Okay, and then you have this. Let me show it one by one. Okay, so first you want to see if the navigation has finished. If you're there already, then don't bother processing. Okay, this is just for us to make it not waste any energy. Okay, so return just makes it such that the loop will end. Okay, if you're familiar. Now then afterwards you'll get a direction. We have to define this variable direction first, so we'll define direction up here. Okay. Okay, hold on. Where's next thing? And we also need a speed. So this constant will be a speed, just like the missile, just like the player. It's going to be a constant speed of 300.0. Speed, sorry, 100. We don't want it to be surpassed. 100. 100.0. And then we're going to give it a friction. Okay, this is another topic to cover, but this is the movement, make it a bit more fluid. short friction, and we'll make this value 1. Okay, this is basically just a kind of like a placeholder for me to define what is LERP. LERP stands for linear interpolation. Interpolation. So LERP. So what LERP does, right, is that it's two values. Yeah, it's a value. Specifically, the vector LERP will take a value that is currently a velocity and will try to move towards the direction. So the direction, right, will, for example, your current velocity is 1, 0, which is towards the right. Then the direction it wants you to go is 0, 1, which is down. To do that, it will now LERP towards that direction. In other words, it will move towards it. And how fast it moves towards it will be by friction. The property friction. Okay. And then the new velocity will be set to this LERP value. Okay, then we'll move and slide to make the die move. Okay, then now we can play. Yes, what's your question?
Direction set assemblies.
Sorry? Okay.
Yeah, we can't see the full line.
Okay.
It was written on direction.
Oh, direction, sorry. Here, get next path position. So navigation agent has a function called get path position, which basically tells you to get position on the path. Okay?
Okay, just one second.
Yeah, no problem. Okay. Yeah. Okay. So now, let me submit this first since I have a bit of time. Sorry. Add enemy mob navigation. Yeah. Okay, then I'll push. Okay. Oh, now I play, right? And you notice something a bit peculiar. This AI is not intelligent at all. What it's doing is sticking itself to the wall a lot. Oh, it doesn't even know how to get to me. You know what's going on? You can actually enable the debug and see navigation. Wait, what happened? Yeah. Which one?
And minus crashing.
Okay, let me see. So actually let me show you the path. You can actually go to the here, debug, and you can enable the debug to see the arrows.
Oh, okay. I don't know what's right.
Okay, then. Yeah, you notice that this line is too tight towards the bound. Okay, it generates a path for you, but it tries to cut corners, and this guy is a bit too fat to cut corners. Okay, so what you need to do, right, is to actually make the mesh. You can actually cut the edges to make some move across it. But what's better, right, is to actually make the mesh a bit smarter. So the navigation mesh is allowing you to cut corners. Let's not do that. So instead, right, what we want to do is that, okay, what I want to do is that we want to cut away this part, okay? So this corner can actually be cut off. Same for this corner, such that it doesn't go here. And if I'm here, then I want to cut off this corner. If I'm here, I want to cut off this corner as well. Sorry, this corner. Yeah. So what you get, right, is actually you cut off this, cut off this, cut off this, you cut off this. You get a plus shape. And then you tessellate it with the next plus shape. And every single time you encounter a corner, you will actually not pass it through. So if I prove it to you here by drawing, it will not cut the edge. Okay. So let's edit our navigation mesh. Go back to your map. Go to the icon under tileset. Notice that what we have here is a four-sided composite shape, or four vertices only. We want to get rid of this guy. So we can press C to clear, or you can just press these three dots and we can clear the navigation mesh. What I want to do is to define a plus shape. So you press this plus, and now let's do this carefully by carving out the edges. I want to enable grid snap, and let's draw that plus shape. And we connect to the first point, and we now have a block string. Okay. So to prove it to you, I'm going to press play. Okay, so what I want to do is, I notice that there's this bug whereby if I'm just like kissing the guy, I'm not moving, I don't die. Okay, so here you can enable grid snap. And then now you can see the grid property. They come out that task just like with the incoming out cookie. And this is a bug you can fix by making that in the third one with this vehicle. The signal is not being emitted and because the guy is he's not actually emitting the emitted signal.
Must have keeps crashing.
Okay, that's
It will just not completely crashing. Okay.
Since they have one different global position in base character body entity. So global for yeah, in the let's see. Yeah. Okay. Yeah, he was here. So yeah, you can put me here for them to kind of get it. Let me finish this off. We are very close to finishing off.
Yeah.
Okay, so I'm going to make a spawn point to constantly emit enemies. This is something that is not new to you. You actually have done it before. So I'm going to go to the game. I'm going to remove all these 5 guys. And I'm going to make a spawn point. Okay, we can make a spawn point by creating another node. This node will be another node because it's not a generic 2D node. And this is called the position, or more like used to call it position. Now it's called a marker. What is the marker 2D? It's basically a point. An area is a shape, right? Marker 2D is just a point, a single point. So when you create spawn points, it's a point. And so we can just use a marker 2D. A marker 2D, and we rename it as spawn point. Okay. Now, a spawn point will be saved under scenes and it will be saved under mobs. I'm going to save it under mobs. Okay. Because it's a mob spawn point, so I'm going to save it under mobs. And I'm going to attach a script because this spawn point's behavior will be to spawn another enemy every 5 seconds. So you know what that means? It means that you need to have a timer. So you go up here, you create a timer, and you call it the what's it called? Spawn time. Okay. Then you should know by now, you connect the spawn time mod signal to yourself. And then you call the spawn function. Okay. What's the spawn function? Let's define the spawn function. The spawn function will create a new enemy node. Okay. But let's say you have more mobs. Let's do it in a way that is more prudent. Let's say you have multiple different mods, mod 002. So we don't want to say, hey, let's spawn this mod 001. We don't want to like say variable or something, preload or something. Okay. Instead, right, we'll make it ambiguous. We'll say enemy And now we won't define it. We will let our editor define it let me define it in the editor. So I'm going to export, and this will be a packed scene. Okay, this annotation in this case, right, is important because it defines the field, what kind of acceptable values it can have in the field. So if I Control S and I go to the spawn point, and go to the inspector. Okay, wrong one. Where enemy pack scene? Let me just do a sanity check. I don't have this. Spawn point. Mob. It's a mob pack scene. 1 year. Yes. Let me just call this mob instead. Spot the difference. I don't see any difference. Oh yeah, the timer is okay because I mean, I was lazy back when I was doing this. I was preparing this. Okay, maybe it's because it's not being used right now. That's why maybe it's not there. Okay. Anyway, I'm gonna spawn. To do this, you will know by now is to create a mob, and this mob will be the mob.instantiate. Then you will add the mob to this as a sibling, which is under the game. So you get the parent, similar to what we did. Get parent, got add child, and we're gonna add the mob. Then we're gonna make this mob global position, the hour position. Okay, we're done. Okay, now it shows up. Okay, good. Yeah, I mean, it's kind of like smart. So now it shows up because I've used it in the function. So this mob, right, is currently empty. It is only accepting a new pack scene. So what I'm going to do is that I'm going to drag and drop my mob scene into here for it to know that I'm supposed to spawn mob 001. So I go to mobs in the scenes folder, and I'm going to drag and I'm going to drop it here. Okay, and it knows to spawn the mob scene.
Mobs open.
Yep. So on the right side, because you have said that this is going to be export, and I'm going to accept a pack scene, because its type is pack scene, I'm going to say that you can drag and drop a mob pack scene here. Okay, now let's go back to the game, and let's add that spawner in. So Control-Shift-A, and we're going to add a spawner. The spawner is going to be at 0, at start. So you want to move this spawner, this point, and make it here, for example, right on the nose. And then it should spawn over there. So let me do a test. And it's not doing anything. Yeah, hold on. Yes, did something happen?
I'm a bit behind. That's okay. No,
Does it still crash?
I'm not only.
Hmm.
We put mob.tcm in spawn point.
Yes,
Okay.
mob.tcm into spawn point here.
Yeah.
Okay, let me debug by looking at the remote main game spawner. On time doesn't do anything. Okay. Oh yeah, it's because it's not even auto starting. Sorry. Go here and you press auto start because the timer's not even starting. Okay, then I press play. Okay. Now it's coming over and all of them are slowly going towards me. I'm gonna go in my hiding corner over here. And all of them will slowly come towards me. And then I'm gonna camp here and kill people. In fact, this missile, right, is actually supposed to delete itself after pressing one guy. Okay, and maybe it's not even fair that it's fucking through walls. Okay, so there's a lot of other improvements that we can make, such as to make this missile delete itself. What you can do, right, is that whenever the enemy receives the damage from the missile, you delete that guy, delete the area. So what you can do here is that in the mob scene, you can actually just kill free the area. And then, oops, Q3 call after 0. Oh yeah. Sorry. Yeah, so this is area.q3, but the function belongs to the area. And then reach that. Okay. Die. Okay. Yep. As you can see, the missile destroys itself when it touches the enemy instead of passing through people. Okay, so you can see that when I die, because I'm really cheated, oops, it crashed. Now, why did it crash? It's because, right, there's one bug that we didn't account for. These are called test cases in your software testing. The reason why it crashed, right, is because the navigation area is unable to sense the player when it's not even there anymore. So you can't even get the node player when he does not exist. So what you want to do, right, is that you want to check if the player exists first. So that node, okay. Let me do a sanity check just in case. Okay, this one. So if parent.getNode player returns something, anything, then it will run something. So what this means is that, and you have to tap this here by the way. So what this means is that it's okay, so let me end this class because I have like 2 more minutes left. And okay, let me disable the debug features. So visible. And let's see the game in its full Stephen Harden glory. Okay. 1, 2. I can kill people. Missiles, 2 hits, 2 shot people. This is yeah, and that's it. Okay. Okay. Anyway, I will help you all later on. But for now, I officially end the session. You have learned a lot of things throughout. I try to go as broad as possible. AI, how to dance, the fawning of themes, export, annotations, all that. And I hope you've learned something. If you are interested in doing more game development, you may join game development group, which I will post and promote later on. And you can join us tomorrow again for more to learn more things such as Unity, Godot, music, and art workshops. Yeah, our club is registered under School of Computing, and it's kind of like a varsity thing. We host game jams, and we allow you to make games and collaborate with other people who are like-minded like you and want to make a game that and realize your idea to come to fruition. Okay, and that's all I have to say. Thank you so much for coming, and have a nice day. If anyone has questions on Zoom, they may stay back and ask. I got kicked out from Zoom. Okay, thank you. Okay, yeah. Control alternate H. Oh, it's there. Sorry. Okay. Okay. Yeah. Thank you, John, and everyone on Zoom as well. I will stop the recording soon. Okay. And I'll answer the people's questions here first. Oh, you didn't get back. Okay. Okay, so it's spawning over there. That's because you did not specify where the guy will be. The spawn point, you need to move him over there. It's a bit hard to see. You understand what I mean? So you need to go to your map, and your spawn point is actually the spawn point is going to be in that area. So you want to move it to somewhere that is not like that. You might want to make it less closer to the guy's collision shape. Yes.
Unfortunately.
Electrical?
Yes, unfortunately.
You want to be electrical?
No.
Oh, why?
Electrical was the third choice and I applied computer science, computer engineering.
Yeah, you can. How much you stuff? I don't know. I don't know.
Yes.
Yeah. Some people some people who are skilled on computer engineering, it's a bit difficult to transfer to computer transfer to computer science because of all the CDE mods, like ECE and all that stuff. Like what system thinking, other more effective. USDG stuff. So because of that,
From computer engineering to computer science or
electrical engineering computer science, I think it's too far. But a lot of things.
okay.
Yeah.
Okay, thank you.
Yeah, thank you. Can I see your spawn point GD inspector tab? So he's talking about spawn point inspector tab. Should be here. Should be all start. Yeah, does that answer the question, Justin? Yeah. Oh wait, oh yeah, I have moved on it. Sorry. Yeah. So this thing, right, is actually the scene here. So what you have to do, right, is that you go over to your mob.001 TSCM. Then afterwards you drag and drop it into the mob. Okay. Okay, my mob is not spawning after moving. That's because the navigation area is not working. So the navigation might not work because your timer might not have auto start as well. So you take a mob and you see the timer if the auto start. And the mob timer should auto start here and run this function. Is okay? Is everything okay, Justin? To get Unity. So then slow. Okay, yeah, thank you. Have it yet. Okay, I'm gonna stop recording now. Thank you, and to all those watching on YouTube.